Hey everyone. So in the last video we have done with the methods of NumPy. In this video we are going to cover the indexing and slicing. That is, we have also done with the lists, and that's nearly same like the lists. So here if you have a list, or we can just create one with the np dot array, and we will use the range function instead of this one. So we have, and let me create something like from 1 to 20 or 21, so that 20 will also be included. So now x here we have this one 1 to 20. Now same to like the list, if you want to access any element, like I want to access 9, so it will be on the index 8, and here we have 9. If you want to access element from negative, then we have here -1 on the 20. You can access any element you want to, like 13, here we have 14. And slicing also same for the 1D, that is, you can just use like from 0 to up to 10, you will have 1 to 10. And here we also get the 10, but we did not get the 10th, or we can say that the range on that one. Actually this 10 is for 11, because the 11 is on the index 10, so I have used that 0 also, otherwise it will confuse you a little bit. So here we have this one now, and if we do the same things here, we will get the results like these. And now here we have 9 when I begin from the 0, and if you want the last one from 10, like from after the 10th, you can do something like this one, then you will get the upper portion, that is from 10 to 20. Here we have up to 9, and you can slice portion like from 2 to 5, then it will include 0, 1, 2, from 2 to 4. Upper will not be counted. So here when you hit enter, you have 2, 3 and 4. So that's how you can also split the lists, and here we have up to 9. So this is the slicing of lists, and that one is indexing in case of 1D. Now one more thing about the 1D slicing is like, here we have done this. If you want to have slicing with negative ones, then if I do from -10 to -1, you can just pass the values in negative. So that's how on the -10 we have the 11, and we have done up to -1. So here 20 will not be included, because that one is the range. In that case here this one is range. So that's how you can split the list with negative numbers also. Now another thing, that is something like if you have a variable y, and that is equal to x of, like, let me take something like from 5 to 15, and you assign them a value of like here 40. Hit enter. If you print y, you will have the numbers of element that will be in 5 to 15, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 15 is not included. So 10 element, but all the elements will be equal to 40, because we have assigned a value 40. And now if you try to print x also, the all elements that are in there replaced by 40, because this slice portion that the variable y has now is the same part of this one. We are just visualizing that part, and if you make any changes with that, the changes will also occur in the original one. So to make any changes in any of the list, you can just copy that list, and to copy just write x dot copy, then the parentheses, shift enter. Now if you print y, you have that one equal to x, that is 0, 1, 2, 3, 4, and then all the 40s up to 15, then from 15 to 20. Now you can make the changes in y directly, instead of making changes in x and assigning that to y. Now the original will not get replaced if you do this same thing, like here this one, command C here, command V, and now this one is already y, and let this one be 80. So shift enter, if you have y now, all these will become 80 and the x is like the original one, that is with 40s. So that's how you can make changes in any list by copying that list and performing the operation. So in the next video we will do the same thing with 2D array or 2D matrices. So thanks for watching and see you in the next video. Hey everyone, so in this video we are going to learn the indexing and slicing in 2D array. So for that, let's just create a 2D array by using np.arrange and a list of, we have 50 elements this time, and then we use the reshape to define the order, that is 5 cross type, or just use 25 elements, that's also enough for demonstration. So here we have this one and print x, here we have. Now to access any element in this one, we have two different methods. That is, first one is something like the list, that is pass the first element 2 and then here 3. That first one is denoting the row, that's I, and this one is j. So if you want to access this 12, then how you can access this one is first in row 0, 1 and 2. So the row will be 2 and the column will be 0, 1 and 2, that's also 2. Hit shift enter, you get the 12. If you want to access 22, then it will be 4th row and second element, so the second column. So that's what we can use the indexing in 2D array. You can also use something like x and just parentheses. This one is in Python 3. Like for first 2 we have the error that may not be happened here, but sorry, this one is this, just shift enter. So that's not the parentheses, that the brackets there, I got a little confused in that, so sorry for that. Here we have this one. You can do the same with the like 4, 2, shift enter, you got the 22. That's about the indexing. And now what about the slicing? What if you need to slice, like here these 2, 3, 4 and 7, 8, 9. So how you can slice that? So in this, just like that one where we used something like 1 and then this thing up to that one, we use the same thing but for 2D, and for that we use that one twice, just like that. So if we need to have this part, so first we define that which rows we need. So we need the row from, that is 0 for this one and this one is 1. So we need 0 to 2 because the upper limit is not included. Then we need the columns, that is this column, this column, this one. So this is second, third and fourth. So we use after 2 all the columns. So here hit and shift enter, here we get 2, 3, 4 and 7, 8, 9. You can do same thing with any element here, like if I need to have this one and this one, this square matrix of 6 to 18, we will do something like, let me clear this one here and this one also. Now to have this one, the row I need is, that is first, second and third. So I will go for first to 4 because upper limit is excluded there. Then I will use the column, that is again same, first to 4. Shift enter, you get these elements, that is 6, 7, 8, 11, 12, 13 and 16, 17, 18. That's how you can slice any list in NumPy by using this thing. One more thing that I want to teach you here is something like that is known as conditional selection. That is, if we have we have another one here, that is something like np dot arrange and from 1 to 20. Here we have y, this one. If you want to have something like all the values greater than, just like here we have 12, so greater than 12. When you do this thing, you will get a list of booleans in which all the values lower than that one will be false and higher than that one will be true. And if you need the values there, because this one true false is showing the indexes, we just use again a y here and this one in these brackets, then you will get all the values. So this thing is known as the conditional selection. You can have any kind of this one here. You can also have like less than divisible just by using the reminder. Like if I show you something like the values that have like y, then I use the reminder operator like the percentage there and percentage equal to 0. I think that may work, and this one needs an equality operator maybe. So I don't know what is required for the reminder. And if we work for less than like 4, we have 1, 2 and 3. For reminder we need something like reminder of that with 2 is not equal to 0, or maybe I have divided that one with 0, that's why it's not working. So here we have this one, there I have done 0 because 0 division is not possible. So this is about this one here, condition selection. This one is not used much in any case. I have not even used that thing anywhere till now. Just the operators and operation just help to solve any problem, but still that's something you need to know. That's why I have told you that. So thanks for watching, and we will continue in the next video. Hey everyone, so last video about the NumPy. I hope you find this one very easy because you are now perfect in lists and data types, and that's something like lists. So in operations, first we need 2 arrays to make the operations on. So here we define np.arrange, that is first one 10 elements. Here we have x, now same y np.arrange, but we will take this one like from 10 to 20. There we have y and 3, 6, 9. That's perfect. Now to perform the operations on NumPy, we have something that is very easy. Like you can just add 2 arrays and store them in a third one, like x plus y. Then z will be, when you print z, it will be the sum of them. Like this one is, if I run this one here, x is this and y we have is this. When you sum this, so here we have 10 plus 0, 10. One more thing that I have not maybe told in list, that whenever you add any array, only the elements of same index will be added, like 0 and 10, then 1 and 11, here 9 and 19, so that will be equal to 28. So elements with the same index will be added. You can also subtract that one, then you will get a different result, that is minus 10 for each, because the difference of these all here is 10, because 13 minus 3 10, 14 minus 4 10. You can do multiplication also, then you will get this one, and division also. So what I want to say here is that you can perform any operation on these. So that's about the basic operations, and not even just basic ones. You can do something like trigonometric np dot sine, that is for sine theta cos theta, then the name of array on which you want to do. So here you get the values of all the elements on that particular sign. You can do cos theta, and you can even do log, that is logarithm. You will get different one, and you will get this alert from the numpy that defines that on 0 you have minus infinity. And that's another point here. This numpy will not show you error in some cases, like if you try to have something like x divided by 0, you will not get error, you will just get an alert. So that's one more thing here. Now like the maximum and minimum values, you can also use operations to find them, like np max and here x. There I have used something like x dot max, the same result. So you can find this maximum value with different ways. One more thing here, if I have this one with 12 elements, then we have this one, and I make this one a 2D array here, like 12, that is 3 cross 4. Now this one is equal to that one, and same with this one up to 22 dot reshape, then 3 cross 4. This one not with sign by here it is. Now you can also perform the operation on 2D matrices, or we can say arrays here. In the same situation like the previous one, same index is added here. All the same index will be added, like this one 15 plus 5, 16 plus 6, 17 plus 7, here 13 plus 3. When you get this one, shift enter, you will get 10 plus 0, here 21 plus 11, that is 32. So that's what you can do with 2D matrices also. And if their order is something like 4 3, that the order is different. Now this one is like that one, and this is that one. When you perform this one, you will get error, because to perform any operation, sorry, this one here, now do that one. That's the thing here. When the order is different, the operation will not work on that one, because you require to have the same order in the operation and subtraction. In case of multiplication, these things, that is the column of first and row of second must be same. So if you try to do something like this one, mathematically this thing is possible because we multiply this thing here, but in numpy this one is also not possible. So that's the thing about the numpy operations. Also you can Google the numpy operations, because there are a large number of operations there you can find on Google. Here like numpy operations, and you will get any website there. Go for this one, Skype lectures, maybe not that one, I thought that one is only Skype. So there you will find operations, like here we are getting these that we have done, like np.arrays, and what we are looking for is maybe not here, and we can search for something like list of numpy operations, maybe then we get. So here GitHub tutorials point. So also not here maybe. now here we have now power operation that are clearly defined here with the examples, reciprocal, and all these operations you can find here. So you can also prefer any other website in which you find easily. One more thing, the operations that I need to tell you is like if I have the x, only that one, sorry, this one, only of 12 elements, this one, and you need to find the sum of all the elements, then just do x dot sum. This one is also an important one, I forgot to mention. You will get the sum of all these elements. So that's enough about the operations on NumPy, and we are done with the basics of NumPy, and I hope you find that one really easy, and we will use these NumPy in the next 5 modules that are about the data science, and you will get more clear about these things. So thanks for watching, and I will see you in the next module.